question, and then type your question afterwards. That way it'll make it easy for us to find your questions. So yeah, Grace, just want to answer your first question there. Yes, apply ML, or we're actually not sure whether or not we're going to offer apply ML going forward. This is actually our first time teaching apply ML, so we want to see how it goes, see what the turnout is, and then decide whether or not we will have it going forward. Hey, Ashley, we don't have a link to the slides yet, but we will post a recording of the lecture on YouTube. So you guys will be able to see that. Yes, it will be uploaded to the ACM AI YouTube. You can, and we'll have the link for that on the Discord as soon as the upload is complete. Awesome for everybody joining. We're just going to be waiting a couple minutes for everybody to get here before we get started. Super excited to see everybody here. What's up, everybody? Just a quick message to everybody that just joined. We're going to be starting really soon. We just want to make sure everybody that's maybe coming in a little late has enough time to get here.
For everyone coming in, make sure to mark your attendance in the ACM member portal. The link's on the slide.
Awesome. So I think we're going to go ahead and get started. It's a little bit past 7:05, so hopefully everybody's here. First of all, I just want to say a big thank you to everybody that's here. Apply ML is actually a new track. This is the first time we're running it. So I just want to say a big thank you for everybody for showing up and for showing their support. So let's go ahead and get started. So before we go into the workshop itself, we have our president, John, as well as our workshops director, Vaishnavi, to just give a quick chat about ACM and our other initiatives. So let's segue right into that.
Everyone, I'm John. I'm president of ACM AI. You might have met me at the AIGM on Monday or beginner check on Tuesday, but in case you didn't, I'll just quickly give maybe a 2-minute overview of what ACM AI does. Next slide, please. So ACM AI's mission is to build and develop a community of students who are interested in artificial intelligence at UCLA and beyond. We are one of 8 subcommittees of ACM, the largest computer science organization at UCLA, and we focus on AI. Next slide, please. Our values are as follows. First, technical proficiency and awareness in AI. All of our initiatives try to either improve your ability to build AI or machine learning models on your own, or understand its impacts on society better. Second, we aim to create a positive impact on society. And while this might be something that might seem very obvious or maybe doesn't need to be said, as you learn more about AI in the future, you'll learn that it's actually quite easy to create negative impact in society without even realizing or intending to. So we want to make sure that we're considering all the ethical implications of everything we work on and make sure that people, including people outside of technology, are aware of AI's impacts. And lastly, our third value is diversity and inclusion. We want to make sure that we have events and initiatives that cater to people of all backgrounds, whether or not you're a technical STEM major or not, whether or not you're rich or poor, whether or not you've done any AI, have any AI experience in your past. We want to make sure that everybody gets an AI education because we believe everyone deserves an AI education. And it's important that everyone understands how AI works, at least at some high level, because it impacts all of our lives daily. So yeah, those are our values. And next slide, please. To accomplish our mission and to kind of basically improve awareness and knowledge of AI at UCLA and beyond, we have 4 major initiatives that we work on. First is workshops. So that Apply ML workshop is one of the examples of the initiatives in workshops. We put on workshops for UCLA students to learn more about how they can build machine learning models on their own. Next, we also have projects, which are an initiative to give UCLA students an opportunity to get hands-on real-world experience with using machine learning to solve actual problems. We also have an events team, which puts on various one-off events for increasing awareness of AI, including Demystifying AI, which is a non-technical introduction to AI, as well as a AI research panel, which is an opportunity for students at UCLA to network and learn more about AI research at UCLA and how they can get involved. And lastly, we have our outreach initiatives, which aim to increase awareness of AI outside of UCLA. And these, the initiatives that our outreach team works on includes our podcast focused on diversity and inclusion in AI, as well as our high school course where we teach AI to high school students. So those are the 4 main things that ACM AI works on. And if any of those things are interesting to you, feel free to contact me or any of our officers. You can contact us also in the ACM Discord or through our Instagram or Twitter or through our Facebook. You can contact us pretty much any way we exist. So yeah, hopefully you are interested in something that we do and want to participate. So yeah, thanks.
Thank you so much, John. So this is applied ML, but we do have other ML workshops as well, as you might know. So beginner track covers introductory theory in machine learning, and that's all. It might be helpful to attend that track in parallel with us, but you definitely don't need to attend both if you don't have the time. But definitely try to come out to at least one of them. If you do have some experience in ML, it might also be useful for you to attend advanced track workshops. For advanced track, we do assume that you have some experience with ML, and typically a lot of students attend beginner track their first quarter here with ACM AI and move on to advanced track after that. Right.
I want to add a couple more things really quick. Sorry. regarding our other workshops as well. We've been getting a lot of questions about like whether you can take multiple workshops per quarter and how often these workshops will be offered. So most of our tracks are offered twice a year. So for example, if you want to attend beginner now, advanced will be offered again next quarter. So there's no need to try to fit as much content as you can within one quarter. And I also got a question in the chat about whether these workshops will be recorded and how important it is that you attend these in person. ApplyML workshops are intended to be as interactive and engaging as possible, and so are other workshops. So it'd be great if you can attend in person, but that being said, all our workshops are going to be recorded and posted on our YouTube channel. Plus, we'll be really active on our Discord channel. So if you have any questions, just send us a message and we'll get back to you as soon as we can. And all our material will also be posted online on our membership portal, the links to all our slides. So just be on the lookout for all our resources, but if you can attend in person, that would be great. And Vaishnavi, by the way.
Awesome. Thanks for that, Vaishnavi. So, yep, that was a little bit about ACM as a whole and our workshops committee. So now let's start talking about the Apply ML track specifically. So just a few details about the Apply ML track. So first thing is who it's for. So Apply ML is for anybody that is interested in, like it says on the slide, learning how to quickly work with data and build models. So what we found with a lot of our tracks is that they focus a lot on the theory. And in Apply ML, we wanted to focus on the applications of ML specifically. So we wanted to talk about how to pre-process data, how to quickly apply models, and then how to evaluate those models as well. So those are some of the things that you're going to be learning in Apply ML. So yeah, I guess that segues nicely into what exactly we're covering in Apply ML. So yep, like I was saying, we're going to be talking about data visualization. We'll be using libraries like Matplotlib and Seaborn for that. We'll be talking about model implementation with scikit-learn, and of course, model evaluation as well. And then, of course, the most important part, when are the meetings? So meetings are going to be every Thursday from 7 to 9. We don't expect that every meeting will go all the way to 9. So, but we did want to block out 2 hours because a lot of the times meetings tend to go on a little bit longer than we expect them to. So now let's talk a little bit more about what specifically Apply ML will be covering and the specifics of what you're going to be learning. That's on the next slide. Okay, so let's talk a little bit about the ML training pipeline. So all machine learning models are built on data. In order for a machine learning model to learn something, it needs a lot of data on the thing it's trying to learn about. So let's go from left to right on the slide, and I'll walk you through every step of this pipeline. So of course, first you start off with the raw data, right? This is the basic data that has all the information that you're trying to learn from. Next, you validate this data. What this means is that you take the data that you have and make sure that it's accurate and make sure it is somewhat distributed as you expect. The next is data pre-processing. This is when you clean out the data. You take out any outliers. Put the data in a format that is easy to read by the machine. Next is model training. Of course, this is one of the most fun part of the pipeline, in my opinion. This is when you're implementing, say, your logistic regression, your linear regression, your neural networks, all that. So that's the model training itself. Next is model validation. Now that we've trained the model, how is this model working? Is it doing what I expect it to do? Is it performing well? Is it overfitting? Is it underfitting? And then finally, once your model's ready to go, you deploy that. So, if in that entire spiel I just gave, you didn't understand a lot of the terms, no worries. That's what you're here for. The point of Apply ML is we want to teach you to be able to do every single part of this pipeline. And that's what we're hoping to accomplish with this track itself. Awesome. Cool. So I'm now going to hand off to Varun, and we're going to talk about how we can get you started with the Jupyter Notebook itself.
Cool. So building on what Harsh said, I'm just going to talk about what we're going to cover broadly in this workshop series. So we're going to start off by just learning how to work with data. So real world data is often messy and requires a bunch of pre-processing before you can actually do anything useful with it. And this is definitely a useful skill to have. So in our first workshop, we're basically going to talk about how do you treat your data before starting to do actual ML work on it? And in fact, in most data science and real world ML projects, this is the stage you're going to be spending the most time on. And so we feel that it's important to learn about this. After we learn how to clean data, then we're going to talk about building some simple classification models like logistic regression, decision trees, random forest KNNs. We'll also be looking at how to build a neural network. For all these models, we'll also learn how to evaluate them. Basically, we'll be looking at different ways we can test our model, different ways we can evaluate our model on a bunch of different benchmarks. How do you communicate what your model does to other people, and so on. And then this is what we're going to be covering in our first 4 workshops, where we'll essentially be coding together. We'll have a notebook open together, and we'll walk through the code with you. Finally, after learning about this for 4 workshops, we're going to have a do-it-yourself project where you'll be applying the skills that you learned in these 4 workshops on a project on your own. So we'll throw you a data, after you guys have picked up all the skills you need to learn, we'll throw you guys a data set, see what you can do with it, and just play around, try to build an ML model, and see what happens. So you'll be able to apply your skills once you learn the various components involved in a machine learning model for the first 4 weeks. Right. So let's get into how we're going to go about this workshop. So we're going to be working through a notebook. So,
I just dropped the link to the notebook in the chat for everybody that's on the chat.
Okay, cool. So what all you guys should do is essentially open this link up, make a copy in, so basically download this file and then open it up with Google Colab. So I'll be showing you guys how to do it. I know it looks messy. So just download it. And then after this, what you want to do is you want to go to Colab. So so Google Colab is basically a platform that Google's provided for you to run code online. And we feel that this is the best way for everyone to be on the same page. Harsh, if you can just drop a link to Google Colab in the chat.
Yeah, sure. That link is on its way.
Yeah. So once you go to Colab, click on File and then Upload Notebook. And you can choose the file that you just downloaded and open it up. We wait a couple of minutes for everyone to upload the file.
Yeah, let's go ahead and give everybody until 7:23 to upload their file. And if anybody is having any issues with that, please drop a note in the chat or just come off mute and ask for help.
Meanwhile, while you guys are also uploading the notebook, this is a quick poll. No worries if you don't feel comfortable answering, but
Awesome. So it seems like a lot of you guys are saying that you guys are either 1 or 2 in your confidence in ML. You know what? That sounds great. When I first joined my first workshop, I would have put my confidence at a 1 as well. And, because of ACM AI, I was able to learn a lot. And hopefully that's the same for you guys. Looking at, have you used Pandas or scikit-learn before? Seems like we're at a 61% for no and 39% for yes. So, if you have used them before, hopefully this workshop can help you refine your skills and really hone in on using those well. And then if you haven't used those before, hopefully, we can build up your knowledge from scratch. And it's cool to see the distribution of what year of college you're in. It seems like we have 50% freshmen, 20% sophomores, 20% juniors, and about 10% seniors. So awesome to see that distribution. Glad to see my upperclassmen are here representing as well. All right, so just about 15 more seconds to upload the Jupyter Notebook. Has everyone been able to do that? No. Okay. Varun, do you want to work through the entire process of uploading it one more time, just so everybody gets a second visual?
Yeah, sure. So what you want to do is if you click on the link that Harsh sent in the chat, I'm just going to send it again. Open this up. And once you open it up, you should be able to download it. Over here, I'm not going to download it again. And then once you've downloaded it, go to Colab, and then click on File. And once you click on File, go to Upload Notebook, and choose File. It should be there in your downloads. It should be called just workshop1.pynb if you're downloading it for the first time. And yeah, just open that up, and you should be good to go.
Awesome. Is anybody else having any issues with that? Please feel free to drop a note in the chat or to come off mute. This is probably the most important part of the entire workshop here, because we're going to be working through the Jupyter Notebook exclusively from now on. We're going to be jumping away from the slides. All right, going once, going twice. All right, looks like we're good to go, Varun. Let's jump into the Jupyter Notebook. Okay, so before we go into the actual code and scikit-learn and pandas and all that, we wanted to just take a quick second and talk about the Jupyter Notebook, because it's very possible that a lot of you guys haven't used this before. So I think the traditional method of coding is, you open up some sort of document, whether that's a VS Code document, or you open up Eclipse, which is your IDE, or you open up PyCharm, which is a Python IDE. And, you type some code, and then you hit run, and your code runs from the top all the way down, right? And then let's say you mess something up, and you make a change, and you run your code, and again, your code runs from the start all the way to the bottom, right? So what you see in most generic IDEs or editors is that whenever you run code, it runs top down, and the entire code runs again. So even if you have a very expensive operation at the top and a relatively cheap operation at the bottom, every time you run the code, that expensive operation and that cheap operation are going to run again. The beauty about Jupyter Notebook is that it allows you to split up code and then only rerun sections of the code that you actually want to. So let's take a look at the example in the notebook we have here. So Varun, if you could run that first cell.
Yeah, sure. And
okay.
If you just think that you guys stay on track with us, keep running the same cells that we're running, and let us know if you have any problems with that.
Right. So here's what happened in this section. So first we have what I wanted to do here was try to simulate that expensive operation as well as that cheap operation that I mentioned earlier. So that expensive operation is the time.sleep5, and then the cheap operation is just printing out the current time and then saying, my name is Harsh. Feel free to replace that with, your own name. And the problem here is that every time we want to print out the date again, we have to wait 5 seconds again, right? Because if we hit the play button, we will wait 5 seconds and then we'll print out the date, right? But in let's say you have some ML model, right? And there's a very expensive computation step that, let's say takes like 2-3 hours to run. And then there's a very cheap step at the end, which is just like printing out the data or making a small change to the data. Every time you make a small change to the data, you don't want to run that 2-3 hour expensive computation again, right? So what Jupyter Notebook gives you is the ability to split those operations into different cells. So that's what we've done in cell 2 and 3. So now what we can do is we can hit play on this first cell and we will wait the 5 seconds. Varun, do you want to run that next cell?
Yeah.
Right. So we will run this cell, right? We can wait the 5 seconds and we'll see when those 5 seconds are up. Okay, those 5 seconds are up. And now we can print our date time. So hit that. There you go. And now if we repeatedly click play, we'll continually print out the date over and over again without having to wait for that expensive operation. So that's the beauty of a Jupyter Notebook, is that it allows you to split up the operations. And if you have a very expensive operation, only run it once, and then run the cheap operations over and over again. Okay, so let's talk about a few more Jupyter Notebook basics. So one caveat in a Jupyter Notebook is going to be explained by this following code here. So Varun, can you hit play on that right there? X equals 0. Okay, and now before Varun hits that, before Varun hits the next button, I want everybody to go in the chat and tell me what will happen when we print X. What value is going to be printed to the console? Just type it into the chat. All right, awesome. Seeing a lot of ones. 1, 1, 1, 1, 1. Great. All right. So Varun, can you hit that? Let's see what we get. Awesome. Okay. So now what I'm going to have Varun do in just a quick second is I'm going to have Varun hit play on this code chunk again. But before he does that, I want everybody to go in the chat again and then tell me what they think is going to get printed. Awesome. So it looks like you guys got it. Varun, hit play for me. There you go. You see 2. And if Varun keeps hitting that button over and over again, you'll see that X just keeps getting incremented. So what's important to note here is that the Jupyter Notebook pretty much has a memory, right? And it's going to remember code that you've run in the past. And so X's value will be remembered by the Jupyter Notebook. And every time you increment X, X is going to increase. What this also means is that in a Jupyter Notebook, it's important to run code in order. So if you have code block A, which needs to be run in order to execute code block B, you have to run code block A and then B in order, or else code block B is not going to work. Okay, awesome. So another thing I want to talk about is, okay, let's say you actually want to reset this X to 0, right? Let's say we just want to start over. How are we going to do that? So if you go into runtime, so Varun, if you could go into the runtime tab and then just hit restart runtime. Awesome. And then now if you could hit play on X plus equals. So this should throw an error. Cool. So why did this throw an error? Because we restarted the runtime, we pretty much reset the memory of our Jupyter Notebook, which means that the Jupyter Notebook no longer knows that we have a variable called X equals 0. So now when we hit X plus equals 1, it doesn't know what we're trying to increment. So this gets back to the point I mentioned earlier about making sure to run the blocks of a code in order. So Varun, if you could run it in order for me again, one time, please. So yep, X equals 0, and then X plus equals 1, and perfect. All right, that's all we needed. Okay, and then just a few more things about navigating the Jupyter Notebook itself. So if you see in the top left-hand corner, we have a plus code button and a plus text button. So if you want to add some code, just hit plus code. And once you do that, it should create a little block where you can add in code and do whatever you want. Maybe print hello world or print welcome, whatever you'd like, Varun. Awesome. And then let's say you want to annotate your code. You want to describe what's happening in every single block. In that case, you can go ahead and hit plus text and it will show you exactly what's happening. And then you can write a description and, say exactly what you want to say. All right. So let's take a quick break right here and ask for questions. Does anybody have any questions about Jupyter Notebook basics, what we've talked about? Please feel free to either drop it in the chat or come off mute and ask your question.
So can you do a demonstration again on how to add a tab?
On how to add a code cell.
Right.
So what you want to do is you want to go here and then just click on add code. So it's going to add a coding cell for you over here. If you want to move a code cell up and down, because the order in Google Colab is important, you can always use these arrows to move code cells up or down. So for example, I could do something like this, where it goes back here and then move it back down as required. If you want to get rid of a code cell, you could just delete it like that. Yeah.
Okay, I think we have a few more questions in the chat. I see one from Tanaya. I hope I said that correctly. I'm so sorry if I didn't say that right. Can you go over how you cleared the memory again? So Varun, do you want to just show it real quick?
Yeah. So what you want to do is you want to go to runtime, and then you want to hit restart runtime, which basically just means that you've not run anything. You go back to the beginning when you just opened up your notebook for the first time. And like we went over before, this operation no longer works because we didn't declare what X is, but you can always run it again if necessary. I just wanted to...
Did that answer your question? Just give us like a quick yes in the chat if that's what you're looking for. Awesome, thank you. And then looks like another question. How did you clear the notebook earlier so that all the cells were blank? Yeah, so usually when you run Jupyter Notebooks locally, like on your laptop itself, there's a very easy way to do this. I haven't actually discovered how to do it on the Google Colab itself. So what I've been doing is on the cell itself, I go and hit the 3 dots on the right. Varun, if you could do that. Yeah, the 3 dots all the way on the right of the cell. Yep. And then hit clear output.
If you want,
and then yep, so that cleared the
like
output.
this. If you go to the output on the left, you can just hit cross.
Yep, or that. There you go. Awesome question. Does the runtime state stay saved even after you exit the page, or does it get cleared every time? I am not 100% sure how it works on Colab. Because Colab is cloud-based, I would assume that it gets cleared every time you refresh, but don't take my word for that. I'd encourage you to test it out yourself and just let us know in the chat.
Yeah, I think the output cells stay, but the state of the local variable, the state of the variables does not remain, if I'm not wrong.
Awesome. If that is all the questions, let's go into the next section here. So reading in the data. Awesome. So of course, with every ML project, you're going to have some data, right? This data is what your ML model is going to be learning from. And it's important that we can get that data into a format that we can work with. So first, we're going to be importing a library, which is pandas. It's probably the most important library we're going to be going over today. Varun, if you could run that, awesome. And then next, we're just going to be grabbing the data from a URL that we have. And if you could run that real quick. So what this is doing is this is just going to the URL and then taking the data and then putting it into a format that we can read. Awesome. So the Varun, did you run that cell?
Yeah. So also it's helpful
Okay.
to remember that reading in data is not always this easy. There are many ways to do that. But for starters, reading in from a URL is not the worst way to begin.
Yep. So just in that last block of code, I'd encourage you to just look at the line of code we wrote. We said Titanic data is equal to pd.read CSV and then gave a URL. So what we're doing is we're taking that data, all the data we have on that URL, and then storing it in the variable Titanic_data. So from now on, Titanic_data is going to refer to all of our data that we're looking at. Awesome. So let's get into the meat of it now. So what is pandas? So we have all of this data, right? That is, we just mysteriously pulled in from a URL, but we need some way to store the data. We need some way to look at the data, to visualize the data, and we need some way to edit the data as well. So pandas is a perfect library for that. This is exactly what pandas is built for. So pandas is, like it says right here, an interactive data processing library that is going to let us organize, process, visualize, and analyze our data. And this is pretty much an industry standard package, and pretty much everybody is using pandas, in order to work through their data, in order to clean the data and to visualize the data. So pandas has a ton of functions that are really, really useful for you to, do all those things that I just mentioned. And that's what we're going to be going through in the rest of our workshop today. We're going to be showing you how to use pandas, and then showing you the various commands and various functions that you can run in pandas to help you work through your data. So first thing, so all data in pandas is stored in something called a data frame. So Varun, if you could run that and show everybody what exactly a data frame looks like. Yep, so this is our data frame. So you can see the various columns and various rows. So this is Titanic data. This is data this is data about every single passenger that was on the ship when the Titanic sank. So if you can see all of the different values we have. We have the passenger ID, whether or not they survived, what their name was, what their sex was, the age, the ticket, where they were in the cabin, a whole lot of good stuff in this data right here. So what we're going to be working through in the next few workshops is building a model that is going to predict whether or not a certain person was able to survive the sinking of the Titanic. So just taking a look at this data frame right here, I wanted to just have somebody come off mute, maybe a volunteer, and let's talk about what features do you think would be useful in predicting whether or not somebody survived, the sinking of the Titanic. If you have any ideas, feel free to come off mute and just shout out your answer, or just drop it into the chat.
I think
Probably
fair
not.
would be useful. Yeah, because of usually in the Titanic, if someone was richer, they were more likely to get on a lifeboat. So
Right.
people who paid more higher fees are more likely to survive. I also think it's something that can be easily analyzed because fair is numeric, so you can easily make a numeric scale.
Yep, that's a great observation about the numeric scale. We're actually going to be talking about that a little bit later during this workshop, but great observation, Ashley. Anybody
I think
else?
P-class also helps. Sorry. I think
What's that?
P-class would also help as well,
Okay.
because I think that also correlates with fair. The
Right.
greater the fair. I don't exactly know if it was first, second, or third was the people with the richer status, but I think it would definitely help.
Right. Yeah. Actually, that's a great observation. I think just looking at the correlation between P class and fair, if you see that P class 1 has a fair of 71, then P class of 3 has a fair of 7. It seems like P class of 1 is the premium class, and then maybe P class 3 and 2 are maybe the economy classes. But yeah, awesome observation. Anything else? Oh, looks like the chat is blown up. Okay. Yep. Daniel says P class. Awesome. Nicholas Tucker says class and gender. Noah also says gender. Awesome. Awesome. Age combined with gender. Interesting take. Awesome. Okay. Well, yeah, these are all great points. The great thing about machine learning is we don't have to decide this for ourselves. The model itself is going to be able to tell us, which ones are the most important features that the model ended up predicting on. So, all right, let's continue. Let's keep working through our notebook here. Awesome. So let's start off with just some quick exploration, right? So usually when you start off working with your data, you just want to see what the first few rows look like, and what the headers are of each row. So we have a very easy function to do that. Just say your data frame and then .head, And then, yeah, this will show the first 4 lines because we specified 4 in our head function. By default, if you run Titanic data.head, it will show you the first 5 lines, just like that. And sometimes you want to look at the back end of the data set as well. So you can use something like Titanic underscore data.tail to look at the last 5 rows of the data frame. Varun, if you could just run that for me. Awesome. So you can see these are the last 5 rows, and then data.head, data frame.head showed you the first 5 rows. So yep, that makes sense, right? Head will show you the first 5, tail will show you the last 5. Awesome. I just want to hand it off to Varun now. He'll talk you guys through just accessing rows and columns.
Thanks, Harsh. So just quick check. Has everyone been able to run the cells along with us and just basically stay on track?
Cool. I'm seeing a lot of yeses in the chat. Good to hear. Good to hear.
Yeah, just make sure that you stay on track with the notebooks, because we're going to be using a notebook for every workshop from now on. So it's helpful to stay with us. Right. So now we're going to basically look at how we can access specific rows and columns in our data frame. So if you see, each column over here has a certain name, and we're literally going to first access the column called name. And if you run it this way, essentially displays the names of everyone in the data set. Feel free to experiment a little bit by changing the name of the column. So for example, you could replace name with maybe passenger ID or age or sex or whatever, and you should be able to look at the entire column. So let's just try that quickly. Right. So this is what you can do to just display and just quickly look at any one column. The alternate is, if you want to access the name column, you can also do it by the position. So what this syntax essentially means is the colon says just choose all the rows. So that's what's before the comma, and what's after the comma is basically saying pick up the third column. So ignore the numbers over here. These are just row numbers. This is column 0, this is column 1, this is column 2, and this is column 3. So if you just use this ilock syntax, you can also display a column by the number. And you can do the same thing for rows as well. So you can basically access the first row or the 0th row by just printing out something like this. It displays the first row in this format. So 103 Mr. Owen Harris, that should correspond to what you have over here, the first row. So yeah, that's basically how you display any one column or row. Feel free to play around with these, fiddle around with the numbers and try displaying just different rows. So if you, for example, try to display the 5th row, then you would do ilock 4 and just run that. Right, so are there any questions about how you'd access rows or columns?
Hey guys, quick thing. I just wanted to bump our earlier point on asking questions in the chat. If you have a question in the chat, please prefix it with this @question. So that way it's a little easier for us to identify what exactly the question is. Looks like we have a question from Nicholas. How do you specify a range of rows and columns? Varun, I'll let you take that.
Yeah. So I think that if you want to display multiple columns, you can do something like this. Right. So if you want to display columns 2 and 3, then you could pass in something like this, a small list of all the columns you want. And I think you can do the same thing here as well, though I'm not 100% sure. Right. So you need to put it. all the column names inside a smaller list, and then you can display multiple columns or rows. Over here, for example, this is columns 2 and 3. If you, instead of displaying all the rows, if you're only interested in the first row, you could do something like this, just 0. If you want all the rows again, put this. No one expects you to remember all of this the first time around. In fact, I almost never remember all of this. I have to Google this every single time. But yeah, it's just important to know that you can access the rows and columns. So if you ever need to, you can just Google the syntax and or come back to this notebook and see what you need to do. Right. So let's try a quick exercise. Write one line of code that prints out the age of the person named Mr. Gustav Joel Johansson.
Cool. While you guys are doing that, I just want to address Brian's question really quick. So yeah, Brian, that's a great question. I actually should have talked about that when I was introducing the notebook itself. But yeah, typically, in any IDE or something like that, when you want to show something on the console, you hit print, right? So you can do that in the Jupyter Notebook as well. But the beauty of the Jupyter Notebook is that it will take the last line of whatever you have. Like for example, if we look at the cell that's on the screen right now, our last line is first passenger. And it'll automatically just print whatever is shown on that last line. So that's why we don't have to write print first passenger, because the Jupyter Notebook will do that for us automatically. Great question, though. Yeah, we'll give you guys about 2 minutes to get this challenge done. Let's check back in at 7:50.
Feel free to Google syntax if you need to, because when you're working with pandas, you're never going to remember syntax. It's always helpful to learn or to search for exactly what you need.
A quick question.
Yeah, what's up?
Yeah, so for the cell up here, we did first passenger. We created a variable, but for like the rest of them, we didn't. Why is that?
We created a variable. What do you mean by that?
We did first passenger is equal to Titanic data, but like the one above that, we just did Titanic data ILOC.
Yeah, no particular reason for that. Just if you want to get that Titanic data.iloc4 and then store it in a variable and then use that variable later, then you can do that with first passenger. Sometimes you're just trying to look through the data and see what's there. And in that case, you don't need to use a variable because you don't need that data later. Does that make sense?
Yeah, okay, thank you.
Awesome. All right, looks like we're getting close to 7:50. Do we want a little bit more time on this, or do we want to just show the answer? Go ahead and just type in the chat what your guys' preference is. All right, no answers. Let's just go ahead and show you guys what the answer is.
So let's see, we have an answer here in the chat. Let's see if that works. And unfortunately not. So sorry about that. So firstly, the one small thing I wanted to bring up is that if you look at the names over here, it's written in last name, comma, first name. So if you want to do something like this, you would have to firstly get the name like this. And the syntax goes something like this. So this essentially prints the age of the person named Gustav Joel Johansson. So what the syntax is basically doing is saying, I want all the rows of this data frame where I have someone with this name, and then I want to pick out the age of this person. Yeah, so these kind of small tricks you'll eventually pick up. as you work more and more with pandas. Yeah, so Harsh, do you want to take the next section?
Yep, sure, I got it. Just wanted to stop real quick and ask if anybody had any questions. Yeah, just looking at Advite's answer, I think that one would work as well. All right. Can we go back up? Can someone paste the correct answer to the chat? Yes, I got you with the correct answer. There you go. And that should work for everybody. I'll just give you 10 seconds to put that in and run it because we'll need that little chunk of code later. Okay, awesome. So let's talk about creating new rows and columns. So, a lot of times in your data frame, you want to add in a new row, add in a new column, just add in data, augment the data that we already have. Like for example, maybe you did a little bit of research and you found out that ML models, the particular ML model you're using will work a little bit better when you give an age in months instead of giving an age in years as we have right now. So, if you want to add that into the data frame, it's actually very, very simple. So let's just take a look at this little chunk of code we have here and see what we're doing. So Titanic data, age in months. So what that first little chunk is doing is we're creating a new column in our data frame titled age in months. Then we're setting that column equal to the age column in our Titanic data frame multiplied by 12. So we're just taking our age column, multiplying it by 12, and then adding it as a new column into our data frame. And if you run that code, you should be able to see that. Bang. All right. You can see that age in months, and you'll see that that is equal to, exactly the age in years multiplied by 12. 12 times 22 is 264, I think, hopefully. Awesome. So just using that similar principle, just a quick exercise for you guys. Prices have changed a lot. Prices have inflated quite a bit. If I could get across the Atlantic Ocean for $70 today, I'd most definitely take that. But prices have changed a lot. So if you guys could, just for us really quick, create a new column that will have the current fare, what the fare would look like today if the Titanic ran today. I'll give you guys about 2 minutes to do that. Should be pretty straightforward. And please refrain from putting your answers in the chat. That way everybody has a chance to work on it on their own. And then we'll come back together as a group and then go over what the answer should be.
Also, I see a question over here asking if we wanted to just update the age column, how would we do it? So I would recommend for now, don't edit the columns that already exist. But if you did want to, you could, for example, just say Titanic data age is equal to Titanic data age into 12, and that would replace the first the age column with 12 into that. Yeah, but for now, don't modify the existing data because that will make things messy. So just create new columns if you want to experiment a little bit.
Awesome. Let's give about 30 more seconds for that exercise.
Yeah.
When searching for a name, why were we able to search through the entire column without writing, like say, a loop to search through the array? Awesome question, Edmund. I think that just comes down again to the beauty of pandas. So if you actually formally wanted to write a loop and do it one by one, you can do that as well. But pandas is smart enough to know when you say that you're multiplying a column by a constant, that what you actually mean is to individually multiply every single number in the column by the constant and create a new column. So that's actually just the beauty of pandas. And if you wanted to write it with a for loop, you could, but might as well take advantage of the functionality that pandas has. Awesome. I think that's been enough time. Do we want to go through the answer now, Varun?
Yeah, sure.
Cool.
So this is how you would go about it. So you basically just say Titanic data fare today is equal to Titanic data fare into 11 and run that. And here we can add another code cell to see what it looks like. And if you see, we now have a column age and months, and you can check that it's 11 times the previous one. Yeah, so that's how you'd add a new column.
Okay, awesome. Hopefully everybody was able to get that one in. Okay, just moving on now. So let's say you want to, let's say you already have an existing list of data, right? And you just want to add that into the data frame. How do we do that? So in order to show us how we do that, let's just add a quick column called random that is filled with random numbers. So that's what we do in these first two lines here. We import random, then we create a random list. If you don't understand the syntax that's being used to create that random list, no worries. That's just some Python, some somewhat fancy Python syntax. So then we're going to say Titanic data random is equal to rand list, very similar to what we just did for fair today. And then if you look at the head of Titanic data, you can see we're adding in that random. Kritik asked a question. I don't know Python. Is there a difference between single quotes and double quotes? No, there is no difference between single quotes and double quotes in Python. That's only in like Java and like C and other languages. But in Python, single quotes and double quotes is the exact same thing. Awesome. So right now we've only gone over how to put in different columns. So let's try adding in a row now. So let's create a new passenger. So that's going to be me. And then we're going to give it all the attributes that a certain row has. So Varun, if you could just scroll up really quick and show the attributes. So we have the passenger ID, survived, P class, name, all that. Okay, let's scroll down real quick. So did I survive? Oh, yes, I did. Awesome. Thanks for making me survive, Varun. And yeah, so we're going to add the new passenger in. So the reason this didn't work right here is because we just added in an extra column right above. So we're having a mismatch between the row, which has, these certain parameters versus the number of rows we have in the data frame. So if we count the number of rows or the number of columns we're giving in new passenger, we see there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And then how many columns do we have in our data frame, Varun?
Let's take a look. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15.
15. So I think it looks like we have one extra, and I think that's just the random number. So you could just add in an extra number at the end, and we should be good to go. Perfect. And then if we look at the tail, we should see that, yep, there I am. Chobisa Harsh has been added into the Titanic. Cool. So everybody just take like a minute to yourself, add yourself into the Titanic database as well. And let me know if you survived or not. Question from Noah, is the length of data frame equal to the number of rows? Yes, it is. All right, I think that should have been enough time. Can somebody just drop in a quick chunk of code that they wrote to add themselves into the Titanic dataset right into the chat? If we're adding a passenger, how come we don't have to add one to the length? Great question there. So if we're adding a passenger, we don't need to add one to the length because Pandas is smart enough to know that you added in another passenger, so it'll automatically add one to the length by itself. That's just a Python thing. It'll take care of it by itself. Ashley says, how do you delete a column? And yep, Varun's absolutely right. We'll be showing you how to do that in just a little bit. Awesome. I'll hand it back off to Varun for the exploring our dataset chunk.
Yeah, cool. So we're just going to go over a few useful functions. So with your data set, if you do something like titanicdata.info, you essentially see what all the columns that you do have and what the data type is. So passenger ID is an integer. Um, age is age happens to be represented as a float for some reason here, and object is here actually means a string, and there's just a useful summary to see what all features you have in your data set. And you can also use describe to get some basic statistics about your model. So just stuff like the mean standard deviation, the median, the 25th quartile, 75th quartile, the max, and so on. If you notice, it's automatically calculated only for all the numerical columns. So something like name would not show up in describe. So that's helpful. Yeah. So I think something that you guys might have noticed right at the beginning was that we had some missing values in our data, which is basically where the data is incomplete or people didn't know what the entries were. So if we do something like is NA dot sum, then we basically know which columns have some missing variables. And if you see, we have quite a lot of entries that we have quite a lot of missing data in our table. So this is something we need to work on before we can eventually work on before we can build our ML models. You can also have something called, a correlation. So if you run this, essentially produces something called a correlation matrix. Don't worry if you don't know what that means. But the intuitive idea is that if you look at any one feature over here, let's say sibling, let's say age, and then you look at fair, what this basically means is that if this number is close to 1 or -1, it means there's a strong linear relation between these two variables. If it's smaller, it means there's less of a correlation between them. Obviously, if you see something like age's correlation with age, it's going to be a perfect 1. And this is just a helpful visualization. If you have two variables that are very, very similar, it might not make sense to keep both of them in your final model. So something like a correlation matrix helps you remove unnecessary columns at the beginning if two variables are super similar. You can also visualize the correlation matrix as a heat map with this library called Seaborn, which is basically this correlation matrix interpreted as colors. So this can give you a more visual understanding of what your data correlation looks like. Yeah, and so you can see that there's a negative correlation between P class and survived, which you can see numerically over here as well, -0.33. Yeah.
Yep. Also, just want to make a quick point on that heat map. So if you look on the side, like that's the legend for the map, right? So all the way at white is when you have a 1.0. 1.0 is when you have a perfect positive correlation. So if X increases and Y increases at the same time, then you'd have a perfect correlation of 1. All the way at the bottom, normally you'd have a -1, but seems like -0.5 is our lowest negative correlation. So negative correlation is if something increases by 1, the other variable decreases by -1. And then right in the middle, you have 0, and 0 means no correlation, which means there's literally nothing associated between the two variables linearly. So if you look down like the diagonal of our heat map, you'll see a perfect white diagonal because white means 1. And of course, if you look at the columns, so for example, in the top left, we have passenger ID white with passenger ID, which makes sense, right? A variable will of course have a 1.0 correlation with itself. And yeah, you can see the other numbers. For example, if you look age in months and age, that's also white with a perfect 1 correlation, which makes sense because we just took age multiplied it by 12 to get age in months, which would make sense why they have a perfect 1.0 correlation.
Yeah, so it's fun to play around with such visualizations. If you require others, you can. There are definitely other visualizations out there. You can always explore these libraries and see if there's anything particularly interesting that you find. So we're now going to look at the matplotlib library, which is basically helpful to plot your data and get some visual understanding of this. This code is a little long, but I'll walk you through what exactly it does. So if you run this piece of code, I'll just show you what it does first. It essentially plots an age distribution of all the survivors. So basically, we know that we have the age of all the passengers. So we basically see how many passengers between the ages of 20 and 30 survived, how many passengers between the age of 40 and 50 survived, and so on. And let's look at how exactly we got this. So we imported a couple of libraries that might be helpful for us. And what we did is we created a data set that of all the people who survived the Titanic sinking. And we did that simply by accessing the Titanic data frame and looking at everyone who had this particular column value as 1. So this essentially means all the people who survived would be in survived, and all the people who died, like Jack in the famous Titanic movie, would be in this data frame. And after that, what we do is we once again use this survived data frame that we just created and extract the age column from that. So what does this mean? It means that this data frame consists of the age of all the people who survived. So you can already see why it's useful to learn how to manipulate the rows and columns and so on, because you can quickly extract a certain row, a certain column, and then use that to make helpful visualizations. After that, we basically say num bins is equal to 20, which is essentially to say that we want 20 bins from 0 to 80. And then we just this is basically some plotting code. You can add an X label, a Y label, and then essentially just make this plot. Similarly, over here, we used the ages of everyone who survived. We can also do that for everyone who did not survive. So extracting the age of all the people who did not survive, all the Jacks. And if we run that, we see something like this. Don't worry about these errors. That's simply because we have some missing values. So you can ignore these errors for now. And yeah, so this is the distribution of all the people who did not survive. So are there any questions about this plotting code? Let me quickly look at the chat. So one of the questions is, when do we use iloc to access a column row versus just using the vector name? It completely depends on what you find more comfortable at that point. If you know the name and you want to access it quickly, you can do it with the name. If you happen to know the index, you can use iloc. It completely depends on what you want to do with the data. Any other questions?
Yeah, Moisey, just want to answer your question really quick. So lock versus iloc. So if you specify .lock, then you have to specify a row or a column using the name of or like the label of the row or the column. So we'd actually have to specify like age or age in months. If you use iloc, it uses it indexes it using a number. So if you do like iloc 3, that will get you like your third column.
Got it. Thanks.
Yep, no worries.
So this is a quick way of basically plotting the ages of everyone who survived and everyone who didn't. And you can basically see that you have so the green represents all the people who didn't survive. So you can see that for every age category, you had fewer people who survived and more people who died in every age category. So that's a helpful visualization. Now this exercise is going to be a little tricky, so I don't expect a lot of you to be able to do this, but it's a fun exercise to play with. So try creating a histogram of ages of men, where each bin like this has the number of men who survived compared to the number of men who were unlucky and didn't make it. And then try to create the same plot for women. And let's see if we can make any, let's see if we can get any inference from that. So just to repeat, what we want is essentially a histogram where we have the ages of all the men. And in that, we want to have a plot that where each bin has the number of men in that age bracket who survived and the number of men who didn't. So let's take 3 to 4 minutes for it. This is a little tricky. You could use some of the code over here, but it is a little tricky. So we'll go over the solution in 3 to 4 minutes after you have some time to try it out.
Yep. I mean, when we started this working with the notebook, I think some people made a prediction that, gender would be a big factor on whether or not you survived, saying that either all the men died or, all the women died, one or the other. And hopefully this exercise will show you exactly whether or not that prediction was correct. Varun, I think we have a few questions in the chat. I think one from Cameron and one from Nicholas, if you want to answer those.
Yeah. What do the commas in the initialization of the graph mean? Which commas again? Sorry. I'll just address the next part, the next question until you get back. What is the line n comma bins comma patches doing? So yeah, let's look at that. So yeah, you don't really need to worry about that right now. There's just some plotting syntax. Bins essentially represents like if your age goes from whatever 0 to 80, bins essentially tells you into how many brackets you want to divide that into. So if instead you had a number of bins is like 20 or something, or like 40, you just have a narrow distribution. Instead of 0 to 5, 5 to 10, and so on, you might have something like 0 to 2.5, 2.5 to 5, and so on. So increasing the number of bins essentially gives you more information, but might make it hard to visualize. So depending on your use case, you might want to vary it. Yeah. Honestly, the syntax for plotting is a little confusing. So the best way, honestly, like I keep saying, is if you want to make any plot, just Google how to do the plot and see if you can modify it to fit your needs. Okay, cool.
Okay, so just want to, so we're about like halfway through that time. I just want to check in on how everybody's doing. Have you guys been able to make some progress, or would you guys maybe like some starter code to help you get started with this? Starter code, please. Okay, let me give you the first few lines. Okay, so I just put in a few lines of code into the chat. So let me work you guys through exactly what these lines are doing. So first, in the first line, we're getting the data about all the males. So we're going to say Titanic data sex is equal to male, and then get all the rows such that sex equals male. And then we're storing that in the variable males. Next, we're taking our males column, right? And then we're saying, did these males survive? If they survived equals 1, then we put them in males survived. Next, we grab all the males that died and put them in males unlucky. So that should get all the data for you guys. The next step is for you guys to take this data and then generate a histogram. It should be pretty similar to the code that's already in the notebook. And I'll give you guys about 2 more minutes. Let's wait until about 8:18 to check back in. If we slice a data frame, is that by reference? No, it is not. Anytime you create a slice of a data frame, for example, that male slice we just created, it is now creating a completely new object for you to work with. So any changes made to that male to males will not affect our original data frame. What is the difference between ax.hist and plt.hist? Varun, I'm gonna let you take that one as the plotting expert.
Honestly, I'm no plotting expert. I also typically plotting does, like, if you use plt.hist, it allows you to make a lot of simple plots, but with ax.hist, if you learn to use matplotlib a lot more, ax typically gives you a lot of flexibility, so you can customize your plots a lot more. There are a lot of plots you can make with both PLT and AX, but they're kind of interchangeable, at least at our level.
Quick question from Christian about the Python syntax. So he used the double. Is that ampersand? I think it's called an ampersand. He used the double ampersand to try to write out and in Python. In Python, you don't need to use a double ampersand. You can just literally write the word and that should take care of it for you.
Is there a way to combine these logic vectors into one?
Question, what's the difference between and, comma, and? Yeah, so advice, I think, man, if I remember correctly, I think and is a bitwise operation if you're familiar with bitwise operations. So that's not what we want to do here. We don't want a bitwise operation, so just use the word and specifically. Okay. Yeah, let's go ahead and show the solution for just the males part of it. So I'm gonna drop in the rest of the code into the chat, and then Varun can run it and show you guys.
Typically, if you copy from Zoom chat, it throws up a lot of errors.
Oh yeah, copying from Zoom chat is not the best. Apologies, guys, for that.
For those of you who are getting some weird characters when copy pasting, it helps to do it line by line.
Yeah, Zoom chat's pretty notorious for putting in random characters into your code, so sorry about that, guys.
Right, so let's quickly walk through what we're doing here. So like we discussed before, we're essentially extracting all the males who did survive, all the males who didn't. And then we're basically just creating a histogram of the men who survived versus the men who didn't. And then we're giving that a label. So if we run this piece of code, you can see that most men, unfortunately, did not make it. So the blue is those who survived, and the green is those who didn't. We can now try to do the exact same thing with the women as well. So that part's easy. We can just change a bunch of the code. It's essentially the same code, just changing the variable names. Oh, sorry. Right. And if you see this plot, you'll see that it's a lot different. in fact, in every age category, women were way more likely to survive than sink, which is exactly what the movie taught us as well. So yeah, this was because during the Titanic, women were given priority on the lifeboats. But basically, the idea behind these plots is that in any data set that you have, you can often plot to get some inferences about the data itself. So you can make these plots, try to get some intuition behind what's happening in the data, what kind of relation the different features have with the probability of survival, and so on. Right. So this is just we just covered a few examples of how you can make plots with your data. There are obviously a lot of different ways to do this, and we can't cover all of them in a single workshop. But this should be a good starting point for you guys to try out and experiment with other ways of visualizing your data. So I guess we'll move on to data cleaning. Harsh, do you want to take this section?
Yeah, just before we move on to that, Vern, I think we have a few questions in the chat if you want to get to those.
Yeah. So we have one question. Were the numbers on the axes already set up? No, they weren't. So the plotting library is smart enough to look at what the range of the data is, and it knows how to plot that automatically. So that's pretty convenient. How come we didn't use some of the lines of codes like num bins in the histogram above? We could, of course, but we just wanted to show you different ways of doing things. You can always play around and try to come up with different ways of making plots. Yeah, the number of bins is auto-generated if you don't specify it. That's true. It says label is not defined. Just maybe make sure that your code is the same. I'm not sure why it would not be defined.
Yeah, just notice how we say like label equals survived, unlucky. Maybe you've left that part of the code out. I think it'd be tough to know exactly what you did wrong without looking at your code specifically. So, by the way, we're going to. Okay, it works now. Good to hear. By the way, we're going to be putting out the completed notebook, and we're going to link it once the call is done. So keep an eye out for that. And also, if you guys want us to debug your code or just look through it with you, we can do that once our workshop is ended. Just stick around for a few minutes once the workshop is done. All right, so we're going to move on to the next section now. Yeah, Varun, am I good to go?
Yeah.
Awesome. Cool. So, all right. So what is the first thing we're trying to do here? So, wait, Varun, do you want to just scroll up real quick? Right. Okay. So data cleaning. So now that we've learned like some tools about pandas itself, we want to get into the meat of what we're learning all these tools for. So typically when you get some data, before you put it into a machine learning model, you want to clean the data. What that means is, one, you want to take out any outliers, so if there's like some really weird numbers in your data set, just take those out. And then two, if there's any like weird things that you added into the data set while you were exploring, you want to take that out as well. If you have any NAs, like, or like any blank values in your data set, you want to take care of those as well. And then, so just a few things you want to do in your data set before you actually put it into the machine learning model. And let's go ahead and do that now. So the first thing is, you guys probably remember that we put in our own name. We put in me into the data set. Harsh Chobisa got added into the data set a few rows back. You guys probably had your own names added into the data set. So because that's not an actual data point, let's go ahead and remove that. So Varun, if you could just, okay, it looks like Varun already removed it. And I think you guys are probably going to have to change Harsh Chobisa to your own name in order for that little chunk of code to work. Awesome. And then just moving on. So we also want to drop a few of the columns that we think won't be relevant for the machine learning model itself to learn from. So for example, passenger ID. I don't think the passenger ID, that's just going to be a randomly generated number. So we're going to delete that, and we're not going to look at that for our machine learning model. Cabin, if you guys remember from earlier, Cabin had a lot of NA values, so we're going to go ahead and drop that as well. Random was just something we added in, so let's drop that. Age and months, that was also just something we added in, so we can drop that as well. Name, I highly doubt name is going to have any correlation, so we're going to drop that. And then ticket and fare today, also some extra stuff we added in on our own, so we're going to drop those as well. Okay, so we're going to drop all those and clean out our data set a little bit. In place equals true. I think we had a question in the chat from Christian about what that does. So we had a quick question earlier about whether or not these operations that we do on the data frame are in place or not, or if whether or not those operations we do on this data frame are by reference or not. So what in place equals true does is essentially it makes it by reference. So when we drop these columns, it's going to actually drop those columns in that specific data set that we were referring to, rather than returning a full copy of the data set. Hopefully that made sense. If not, let's chat about it after this workshop is done. Okay, and let's deal with missing values now. So let's hit play on that. Awesome. So just looking at our entire data frame now, we have missing values in 2 columns. So age has some missing values and embarked has some missing values. So there's a lot of different techniques that you can do to address missing data. Sometimes, you just put in fake data and just say, okay, that's okay for this one. We're just gonna, manipulate the data or simulate the data and then put it in. You could also run a machine learning model to predict what those data points should be and then use that data for your next machine learning model. You could also just do something very simple, like just drop the data altogether from the data frame. And that's what we're going to do here. So we know that our data set is rather large. There were a lot of people on the Titanic. So if we just simply drop, or meaning by drop, I mean just remove all the data that has NA values or missing values, that should be okay for our application here. So that's what we're going to do now. Titanic data.drop NA with a subset on embarked is going to drop all the embarked, is going to drop all the NA values in the embarked column. Okay. Awesome. So now you can see we've dropped everything in embarked that had an NA value. Of course, with age, we don't want to just drop all the data for age that has a missing value, because there's a lot of missing values for age, right? There's 177. And our data set is not that big where if we remove 177, it's not going to impact our final result. So rather than dropping all the data points that have a missing age, we're simply going to simulate it. So what we're going to do is we're going to fill in our age for every missing value with the median age of all the passengers on the ship. So that's what we're going to do in this next code, in this next chunk of code right here. So we're going to take the age column and then fill all the missing values with the median value of Titanic underscore data.age. So now that that has been filled, if we run this next chunk of code, we should see that we have no more NA values in the age column, and that is exactly what happens. Awesome. Yeah, so question in the chat, is there a specific reason for choosing the median instead of the mean? Yeah, so usually median is a little bit more resistant to outliers. So usually in like stats and ML, you usually use a median rather than a mean. But that's your own choice. If you want to go ahead and change that to a mean, you can do that as well. Awesome. So now let's talk about one of the most important concepts in data cleaning, which is one-hot encoding. So I think we had a quick mention earlier from somebody that we want to use values that are numerical, because numerical values are going to be able to be processed by our machine learning model. And that was absolutely true. Most machine learning models can only easily handle numerical values. But of course, in our Titanic data set, we do have some values that are not numeric, right? So we want to somehow, change those values so that we can represent them in a numeric format. And that is where one-hot encoding comes in. So let's take a look at this picture that Varun just put up onto our screen here. and let's talk about what exactly one-hot encoding does. Varun, are we able to show the whole picture, or we can't?
I don't think so. Sorry.
Okay. Well, let's just go ahead and scroll to the left and talk about the first part. So let's say on the left here, let's say this is our data set, right? We just have 4 values. If you can scroll all the way to the left, that'd be great. The other left. There we go. Okay, so let's say this is our data frame, and we have 4 values, and we have 1 column for each of these values, what the color is, right? So we want to somehow represent this color as a number, right? So what we're going to do is we're going to use this technique called one-hot encoding. What one-hot encoding is going to do is it's going to create a new column for every single one of these colors. So if you scroll all the way to the right, you should be able to see that. So now, instead of having one single column for all the different colors, we've created 3 different columns for each of the colors that we have. So we have 1 column for red, 1 column for blue, 1 column for green, right? So now what we do is that if that certain ID is red, then we fill in the red column with a 1. If that ID has a color of blue, we can see on the left side that ID 2 has a color of blue. That means we're going to take the color blue column and put in a 1 for that ID. So basically with one-hot encoding, what we're doing is we're just making a new column for every single color. And then we're putting in a 1 for every ID that has that color. So Nicholas has a fantastic point. Why not just use 0, 1, 2, or 3? We could definitely do that as well. That is definitely a technique that you can use, but sometimes that's not the best for some of the machine learning models we have. For example, if you use linear regression, the model might try to learn something based off, how high that value is, rather than just trying to learn something based on whether or not that value is there. So we're just trying to make things as clear as we can for the ML model, and oftentimes one-hot encoding is the best approach to do that. There's definitely some situations where you just want to use 0, 1, 2, and 3, like Nicholas is saying. But I think in the situation that we have here, the best way to go forward is with one-hot encoding. Awesome. So one-hot encoding is a pretty important concept. So I just wanted to stop there and ask for questions. Did that explanation make sense to you guys? And if not, what questions do you have? Feel free to come off mute and ask your question, or just throw it in the chat. All right, going once. No, it doesn't make sense. Awesome. Going twice. And sold. All right. So now that we've just talked about one-hot encoding, we want to one-hot encode some of the values we have. So for example, our embarked column, we're going to one-hot encode embarked. And that's what this chunk of code should do right here. Awesome. So earlier in embarked, we had either port Q or port S. So instead, because we one-hot encoded it now, we just have a column for port Q and we have a column for port S, and it shows you exactly which port that certain passenger embarked on their journey on. Okay, and then scrolling down. So yeah, Nicholas, like you said, one thing we could do is we could just map our colors to 0, 1, 2, and 3. And in that case, that's what we're going to do here with sex, with male being mapped to 0 and female being mapped to 1. And we can just directly map it. And now you can see in our data frame, we have all numbers instead of male and female, which is a string. Awesome. So that is all the data cleaning we're going to do for this workshop today. So essentially all we wanted to do with this data cleaning is 1, take out any stray data like we just did with the missing values, or 2, if we have strings in our data set, we want to change those into numbers because numbers are a lot easier for a machine learning model to process. So now that we've done that, we want to export our clean data. So we want to take our data and save it so that we can use it next week when we actually build a model. So I'm gonna hand off to Varun and let him walk you guys through that.
Right. So now that we've cleaned our data, what we're going to do is save it to our Google Drive account. So what this line of code is doing is essentially connecting Google Colab with your Google Drive account. So you can just save the clean data directly to your Google Drive. So what you do is essentially run this cell, and it's gonna say go to this URL in your browser, go right there, choose your account, click allow, copy this link, and then come back to the come back to the Google Colab, enter this activation code, and hit enter. So in a couple of moments, this should connect your Google Drive with Google Colab. So I'm going to just wait for a minute for everyone to get done with that. If we've been doing this in Jupyter Lab, how do we utilize that function? I think if you don't need to connect Google Drive for Jupyter Lab. If I'm not wrong, Jupyter Lab runs locally, so you should be able to save it automatically. Just have to change the path and make it like a local path in your computer. I'm not 100% sure about that because I don't usually use Jupyter Lab.
Yeah, you can just go, if you look at that last line that we have, that Titanic data to CSV, you should just be able to run that and then choose, and then in that parentheses, just specify the path where you want it saved, and it should automatically take care of that for you. You can just ignore the whole Google Drive portion of it. We just wanted to include that because we're running this on Google Colab, and we figured a lot of people, we figured a lot of other people would be too.
Right. Before we go ahead, there's one question about something earlier. Why not just use 0, 1, 2, 3? I'm assuming this is referring to one hot encoding. And the reason for that is that if you have 4 categories, and if you replace each of the category names with 0, oh sorry, yeah, so you can it's essentially it's easier to just do one hot encoding instead of working with that. Okay, so let's move ahead and let's save this. So once you guys have mounted Google Drive, you can essentially use Colab your Colab cells as a terminal. So you can literally do something like ls. You can also cd into G Drive. This is essentially like using your Google Drive as a terminal. And so because this makes life a lot more convenient, you can literally run this cell and save it to any path that you want in your drive. So to keep it simple, you can just save it to your drive to my drive directly. If you want to save it in a particular location that you prefer, that's fine as well. Just make sure that you remember that for next workshop when we read in this data again. So if you do this, and then go ahead and check your Google Drive, this data should be saved over there. So yeah, that's essentially it. Just to summarize, we imported the data from a source. We spent some time visualizing what the data looks like and manipulating the data and so on. And then finally, we extracted exactly all the columns we need. We dealt with any missing values. And finally, now that we have a clean data set that's ready for machine learning, we save this file to our Google Drive so that we can use it next time to actually build models on this. So yeah, Harsh, is there anything that you want to add?
No, Varun, I think you covered everything. Just want to say a big thank you to everybody that came out to our workshop. Like I said earlier, this is the first time we're running this new workshop track, and we're really excited for everybody to be here. Thanks so much for coming out. And please, 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 since this is the first time we're running this workshop, we really need your feedback so that we can improve this workshop and make it better for you guys. So there's a hyperlink right at the bottom, tinyurl.com/applyml1. That should lead you right to a Google form that you can give us feedback at. So please just take 30 seconds and fill that out for us. We're going to read every reply, and then adjust next week's workshop based on your guys's feedback. So thank you guys so much for coming out. If you have any questions, feel free to stick around on the Zoom and just hang out. Me and Varun will stay on for a few minutes to answer your questions. And thanks again, guys. Really appreciate it. We'll see you guys next week, same place, same time.
Also, guys, for those of you filling out the feedback form, if you can just let us know what your ideal length for a workshop would be. We'll take that into consideration in future workshops.
Yep, seeing a lot of thanks from you guys in the chat. Thank you guys so much. Noah, we're not super sure about the link yet. Just keep an eye on the Facebook event. We'll drop the link in there 1 hour before the workshop starts. We'll also drop a link in the Discord. For now, it should stay the same, but I don't want to make any promises. Question from Gordon. What does drop NA do? Does it drop the NA or does it drop the whole row? Gordon, it drops the whole row. So if you drop NA and give it like a certain column to focus on, it'll drop every single row that has an NA in that column. Yeah, no problem, Gordon. Yep, thanks so much for coming out, guys. Really appreciate you guys. Feel free to fill out that feedback form if you get a chance. Can you explain the in place equals true thing again? Yeah, absolutely. So I think this would be best explained with some code. Varun, do you want to just like code one with in place equals true and one without in place equals true and just show exactly what it is?
Yeah.
So yeah. All right, so Varun just put in Titanic sex dot replace male 0 in place equals true, in place equals false. So now if he runs this, you'll see that the
so it
doesn't actually get updated.
So let's just say something like,
wait, I don't think that's gonna work. Yeah, actually run that. Let's see what happens. All right, so because in place was equal to false, and we did Titanic data, you see that nothing actually happened, right? The zeros didn't actually get replaced with false. But now if we say like, do you want to assign Titanic data to like a variable and then just print out that variable? Maybe say like x equals Titanic data, and then just print out x and run it. Okay, you'll see that now it actually got replaced. Do you see that? It actually got replaced, right? So what happens whenever you run a function on a data frame is that it will return you a new data frame or a new slice of that data frame with whatever change you made. So what happened here is with in place equals false, it returned us x, and then x had the change that we required. But when we didn't have the x, it was returning the change, but we didn't actually have a variable to catch the change, and the main data frame didn't actually change. But if you do in place equals true, it'll actually make the change directly to the data frame in question. So you don't need to assign it to a new variable. Cameron, does that make sense? Yeah, I guess you could say it is a little bit dangerous.
We have a question about using CD and mkdir on Google Drive directly. So it's not exactly like a terminal. So all the commands might not work, just some of the very basic ones like ls or something. So there probably are commands to make directories and stuff directly from Drive, but I'm not familiar with them. You could either make the folders directly on Google Drive and then use that path, or there might be some code to do it directly from Drive as well. But it's not necessarily the exact same as a terminal.
Yeah, I think the main thing, Moisey, is that you just want to make sure you can access this data for next week because we're going to use it again next week. Awesome. If there's no more questions, I think we can sign off. Yep. Thanks, Moisey. Appreciate you. Hey, fill out that feedback form if you can.